Reinforcement learning concept comes from that. It relies on trial and error. Let's say you're telling an agent to perform a particular task. Okay, let's say you're telling an agent, let's say it's a physical robot. Agent can be, I think it's a virtual robot also is fine. Virtual agent or a physical robot. You're telling agent to perform particular task. Let's say you're telling a banana is in another side of a room. Let's say you are in one room and you're telling, please get me one banana, which is there in the other side of the room. So agent, maybe he doesn't know the environment which you're in. Maybe the agent, the physical robot, was trained in different room, different homes, right? In this particular home, you're keeping an agent or robot, physical robot. You're telling it to navigate to a different room. That room, in that room, banana is there, and it has to pick the banana and it has to edit it. That is the goal. Okay, it has to go one room to another room. In the second room, one banana is there. It has to bring the banana and give it. So if he doesn't know what it is doing and you are not supervising, so it is not a supervised learn. You're not telling it go like this, go like that. It has to learn by itself. It is called trial and error mechanism. So it is reinforcing the learning. It reinforces itself. It learns by trial and error. Now, what will the motivation be? The motivation is you give constant rewards. I mean, rewards means what? Okay. If you're going to the right direction, at point stage. If it's a virtual agent, at points. If it's a physical robot, even though, tell it if it navigates for different particular time limit, it will earn a reward. So reward concept comes here in the reinforcement learning. So if it doesn't go in the proper path, you punish it, like remove the rewards or remove the points. So this is in short reinforcement learning, where agent learns everything by itself with a trial and error. It will commit mistakes, it's fine. If it's getting the reward, it will follow the path. If it doesn't get the reward, it will erase that path and will try to do trial and error. It will go to a location. It might take a little bit of time in the beginning, but we also know we have different search methodologies, right? If you remember, recurrent neural network which store the memory, and we also have long short term neural network, or the neural network is there. It stores the long term memories. Let's say we are getting the reinforcement learning with the recurrent neural network, right? First time it will take time, the second time it will remember each and everything. It will try to do it as well. So you got the gist of it. What exactly the reinforcement learning? At least an idea. Let me just read the definition. At least we'll understand a bit of it. Okay. So reinforcement learning is a type of machine learning. So AI, bigger picture, machine learning is subset, deep learning is subset of machine learning. So deep learning is also subset of uh, AI. So it's a type of machine learning where the agent learns to make decisions by interacting with an environment. Okay. So in the example which I gave, agent is trying to move to a different room. Think this entire home is a environment. It has to get you banana from another room. It has to travel from this particular room. So in while traveling, it can interact with the walls, right? But at the time, don't give the reward. Only give the reward if it is traveling the straight path. Unlike supervised learning, where the model is trained on the labeled data, you remember, I think we had discussed the labeled data, unlabeled data also in the previous sessions where we had all the kind of learning and we introduced reinforcement learning. But here we'll go in depth. Here we'll see the types, what exactly it is. So RL, reinforcement learning, relies on trial and error. The agent learns through experiences, receive feedback through rewards or penalties, guiding it toward optimal behavior. Got it? Any question? Just in the definition. We'll see an example, then we can go into. All right. In short, agent learns by trial and error. If it goes to the correct path, it gets rewards, example points. If it goes to a wrong path, it doesn't get rewards. It gets penalties. Let's say point plus one you add for each and every proper step, minus one you add for each and every negative step. Okay. Now, let us see a simple example of reinforcement learning. Let me share Okay, let me see the first. Let me stop the share. Let me see one program where I can show you reinforcement learning. Okay, let us see reinforcement grid. Okay, so now we are taking a we have reinforcement grid, we have reinforcement learning, we have passive, active, and multi-arm reinforcement learning. So yeah, I have just divided in a simple way where I can showcase what is the state. State is what is starting point. You remember a matrix. So if you remember, we used to have a Q-learn where you used to have matrix. The starting step size will be 0, 0, and the ending will be at the end goal where we can reach the end. How the agent navigates, same example, but here agent is navigating through a reinforcement learning. Okay. So if I go to the command prompt, okay, just let me put CLS. Let me share the screen. Reinforcement.py. Okay. Let me click on enter. So here we'll get the answer based on the grid values. Okay. So it was there in the state first 0, 0, and it reached the 3, 3. Imagine this is 0, 0. This is 3, 3. To reach this, uh, it went to an action 3. The reward was -1. Then it went to an action 1. Reward was -1. Action 3. Slowly, when it turned, at the end, you are giving reward. Just like points, how you're navigating through. So, total reward at the end, based on the penalties, based on the reward is actually gained traveling to the path, it got 5 at the end. Okay. Now, you may ask, it can be improved, right? I gave static data, so it should be the same. So if you give the active data in future, it might change. So here also you can see how the Q values are learned. Something it is 3.07, just ignore it. It is 2.94. It can be improved. Okay. So altogether, you don't have to always get 5. You can get a different values also. You might get a penalty, you might get a reward at the end, but it started from one point and it reached to a goal which is size -1. That is what I gave you. If you see the code, starting state will be 0.0 and ending state will be size -1. Means size here is 4, max 4 values we are giving here. If you follow this, this is the 4 value, the maximum size we are giving 4, and we are trying to create a grid world. Grid is basically the matrix from 0, 0 to 3, 3, and agent has to navigate to a goal. Imagine the real life, the real robot is navigating like that. It's getting a banana swing. Okay, it can do a reinforcement learning. If you see the command prompt again, what I'm trying to do, see, run it again. Okay. So you might think what exactly are these values? Okay. So it got +3. Imagine it is going forward. Okay. Minus it is coming back. So each and every time it is traveling at grid position properly. 0 means it reached the goal. So here it reached the goal and it got the reward 10 at this position, and we got from state, um, see, each and every time it is state 0 to 1 to 3 to 3, but goal always is the end point what we have got. Okay. If you have to see the program, if you want to recreate the program, just see how we have done it. Okay. So always we can add a class or a method, and we are using the same numpy. If you have already installed numpy, just install pfp install numpy, and random for generating random values. So if you want to know how the agent can learn by itself, always generate a random value so that agent could navigate. Okay. So import random will introduce the random values in a grid so that agent could navigate. For each and every iteration, it can learn by itself all the time. And the class, we have added grid world till here. We are ending the class at the end, but we are also adding a loop in between. For all the episode, 1,000 times we are running, and the Q table is there. Grid size we are giving 4, and we are calling this function. So we have something called Q learning, non-Q learning. If you go in depth of the deep learning, you'll get that concept. So Q learning basically just understand we are getting the rewards and we are getting the punishment or a penalty if the agent is navigating differently. So if you want to always give the factor, So what is the learning factor? So it should learn only by 0.1. So understanding it like agent is navigating for each and every step, it will learn only 1% or 10% at time. If you take one as a whole thing, it is learning 10% how to navigate forward. It might make mirror in the end. So you can increase this if you want. Let's say 0.5 is the learning rate. You can change this like test data. Okay, control S.